All right, welcome back. This time we're going into Sec2Sec. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Sec2Sec, transforming deep sequences with deep learning, right? So language represents one of humanity's most complex cognitive achievements. So you can encode meaning through ordered sequences of symbols that humans parse effortlessly, but machines struggle to understand. When faced with transforming one sequence into another, translating English to German, summarizing lengthy documents into concise abstracts, or converting spoken audio into written text, traditional algorithms can falter. These techniques require understanding context, capturing semantic meaning across varying sequence lengths, and generating coherent output that respects the linguistic structure. So sequence to sequence, commonly seen as Sec2Sec, emerged as deep learning's answer to this fundamental challenge. Rather than treating sequence transformation as a simple mapping problem, sequence to sequence, Sec2Sec, employs sophisticated neural architectures that learn to encode meaning from input sequences and decode that understanding into entirely different output sequences. This capability unlocks applications that once seemed impossibly complex, from real-time translation to intelligent text summarization. So let's go into some of the architecture. Okay, so Sec2Sec's power derives from its elegant decoder architecture. So this is a design that mirrors how humans process and transform sequential information. The encoder portion reads through the input sequence, whether text, speech, or other sequential data, and it builds an internal representation that captures the essential meaning and context of the entire input. So this encoding processes leverages either recurrent neural networks, RNNs, with variants like LSTMs or GRUs, or convolutional neural networks, CNNs, right? So this is enhanced with attention mechanisms. RNNs excel at capturing temporal dependencies through their feedback loops, maintaining hidden states that accumulate text as they process each element sequentially. CNNs with attention offer faster training through parallelization, while attention mechanisms ensure the model focuses on relevant portions of the input when generating output. The decoder receives this compressed representation and generates the output sequence token by token. Unlike simple translation dictionaries, the decoder learned during training how to produce coherent sequences in the target domain, whether that's another language, a summarized version, or transcribed text from audio. So attention mechanisms. So let's see. Do I not have that here? Nope. Okay. Okay, that's okay. I thought that was, oh, yes, here we go. Attention mechanisms. All right. So this revolutionized Sec2Sec's performance by addressing a critical limitation: the information bottleneck created when encoding an entire sequence into a single representation. Instead of forcing all context through one vector, attention allows the decoder to selectively focus on different parts of the input sequence as it generates each output token. This dynamic focusing capability dramatically improves performance on longer sequences and enables the model to maintain coherence across complex transformations. All right, so let's see. Okay, so applications across language and speaks. Okay, so these are the hyperparameters that will give you some idea. All right, so machine translation represents Sec2Sec's most celebrated application. Organizations can deploy these models to translate customer communications, localize software interfaces, and enable cross-language business operations. The models don't just translate words, they capture idiomatic expressions, maintain grammatical structure, and adapt tone appropriate for the target audience and language, right? So the text summarization transforms Sec2Sec's sequence manipulation capabilities into content compression. News organizations can use these models to generate article summaries automatically. Research platforms can create abstracts and generate them. And customer service systems can distill lengthy support transcripts and chats into actionable insights. So the models can learn to identify salient information, restructure content for clarity, and maintain factual accuracy while reducing length, right? So the speech to text conversion demonstrates Sec2Sec's versatility beyond pure text processing. By tokenizing audio waveforms into sequential representations, the models can transform spoken language into written text, enable voice assistants, automate transcripted services, and accessibility features for hearing impaired users. So conversational AI can use Sec2Sec for chatbots, for virtual assistants, where both user input and system responses exist as sequential language tokens. And the models can learn conversation patterns, they can maintain context across exchanges, and they can generate responses that feel natural and contextually appropriate. right, so data prep. All right, so let's get started. Tokenization challenges. All right, so Sec2Sec's strict data requirements reflect its deep learning foundations and optimization for neural network processing. Unlike algorithms that accept CSV or JSON inputs, Sec2Sec demands RecordIO-Protobuf format with integer token representations. So this is a requirement that initially seems burdensome, but actually reflects careful engineering for neural network efficiency. So the tokenization process transforms raw text or audio into integer sequences where each unique element receives a numeric identifier. For text, this means building comprehensive vocabularies that map every word to a unique integer. Common words like the or and receive their indices, while rarer terms get their own mappings, creating a complete numerical representation of the language. So this pre-processing phase requires careful execution. Sorry, I got a little distracted. So this pre-processing requires careful execution and is provided by SageMaker. There's example notebooks that can demonstrate proper tokenization workflows. And this process can generate 3 critical files: train.rec, which contains the tokenized training sequences; validation.rec, which provides the validation for modeling, data for modeling and monitoring training progress; and vocab.txt, which can establish the word to integer mapping that enables decoding predictions back into human readable text. So the RecordIO/Protobuf format can optimize data loading, neural network training, enabling batch processing, and minimizing IO bottlenecks that could slow training on these computationally intensive models. While the pre-processing requirements add complexity, they enable the training efficiency necessary for practical Sec2Sec deployment. All right. And, all right. So beyond accuracy. Okay. Okay. So Sec2Sec, these models require specialized evaluation metrics that reflect the nuanced nature of sequence transformation tasks. Traditional accuracy metrics fail because multiple valid outputs might exist for any given input, and translations can vary while remaining correct. Summaries can emphasize different aspects while maintaining accuracy, and speech recognition might represent sounds differently while capturing meaning. So something like the BLEU score, right? So this is the bilingual evaluation understudy. This addresses this challenge by comparing generated sequences against multiple reference translations or outputs. Rather than demanding exact matches, BLEU measures n-gram overlap between predictions and inferences. So it provides a partial credit for outputs that capture substantial portions of the correct content, even if not perfectly matching any single reference. This flexibility better reflects real-world sequence transformation quality. And perplexity, right? So let's see. BLEU, perplexity. All right. So perplexity measures the model's confidence in its prediction through cross-entropy calculations. So lower perplexity indicates the model assigns high probability to correct sequences, suggesting it has learned robust patterns for sequence transformation. All right. While less intuitive than BLEU, perplexity provides valuable insights into model certainty and learning progress during training. So these metrics guide hyperparameter tuning and model selections, and they'll help practitioners identify configurations that produce not just technically correct outputs, but ones that feel natural and appropriate for their specific application domains. All right. All right. All right, let's get our hands on this in the console. SageMaker AI, since we recently used that. It's located here. Let's go to training, click training job, training, training jobs, create a training job. All right. So before this, you want to get everything uploaded into your S3, right? So you have to pre-process your workflow. This would be with raw text data or CSVs or whatever, right? It can be whatever language or everything you need. And you need to execute the tokenization to get this to map to the integer index. And you can convert this to the RecordIO-Protobuf format. Let me see. Let's see. Well, Stack Overflow might have an answer. I thought they had one. Um, this will probably be your best answer. All right. Common data formats, content type is associated with algorithms, data conversion, arrays of numbers. So you need a label encoder, one hot coding. Let's see. Data conversion. Okay, so this would be SageMaker Python SDK. Okay. From A array for T and train set. Yeah. Okay, so you could train that and then upload it to the S3 bucket. Okay, that makes sense. All right, so you get that converted using that information, and let's bookmark that just to be safe. And then label encoding. Yeah, that's good. And some one hot encoding. Okay. All right. And then we're just going to show you this just to get this sec to sec test. All right. Then we're going to go, the IAM role. You want to make sure you're using the right one right here. Execution role. Let's say that. All right. Sequence to sequence, text transformation. Okay. So you want to make sure this IAM role though has S3 access, CloudWatch access, and instance provisioning, right? So it's a SageMaker execution role, so it should have that. All right. This execution role should also have it. Really, all of these should, but make sure you check it. And you can check this in IAM in the search bar just to see what is actually scoped out to it. All right. So from here, go down here. Here's the sec2sec. All right, we have our instance. Storage volume per instance, 1 GB. Instance count, 1. That's fine. This is all for testing. Just say 5 minutes. An encryption key, we're not going to have encryption, but you should have it. So we'll have this max runtime set to 1 hour. Network isolation, that's always a good shot. We have the default VPC subnets. Let's do 1A. Let's do 1C. We don't need that. Security groups. Yeah, we'll do this. Inbound. All right. And then this is network isolation set. We don't have to have anything going out being publicly available. It shouldn't be, but basically security groups can isolate traffic to or from resources. Inbound rules are reciprocal to any other resource. So it's a valuable place to go. All right, so then you have to do your hyperparameters, right? So this is where you expose a neural network configuration to parameters that can determine the model architecture and its behavior. And each parameter can influence the aspects of the model's performance. So just consider what you need. So we'll go over some of the major ones that I typically like to look at. Let's see. Batch. Okay, so batch size. All right, so you want to do the batch size. This is like how many sequence pairs the model can process simultaneously during it. So a larger batch size, like 64, can provide more stable gradient estimates, right? But it requires a lot more memory. So smaller batches can train on limited GPUs memory, but may make noisier training dynamics. So 64 is a pretty medium one. You can set it up to 128. You might be able to do 256. You can go higher, but let's say 64 is solid. Let's see, the optimizer. Where is it? I'm not seeing it, am I? Optimizer type. Okay. So the optimizer, okay, so select the algorithm model, right? The optimizing algorithm model, right? So Adam provides good default performance through adaptive learning rates. SGD can offer simpler dynamics that sometimes generalize better. And then RMS prop can provide another alternative that's effective for recurrent architectures. So we'll stick with, we'll go with Adam. It's a good default. The learning rate. Okay, so you control the gradient descent step size. So start with a moderate value, like 0.0003 is pretty moderate. 0.001, and then you can set this there, monitor, see if it increases to 0.01. And you can do this to see if training proceeds too slowly, or you can decrease if the loss values become unstable. All right. Then you want to do let's see, number of layers. Okay. So you want to go between encoder and decoder, right? So you can define the encoder and decoder depth. So deep networks with 4 to 8 layers can capture more complex patterns, but they require more training time and risk overfitting on a smaller data sets. Start with a moderate depth and adjust based on your performance. Let's do 2. Let's do 2, right? Let's see. Max sequence length, all right? So for this, you can establish the maximum sequence length the model will process. The parameter can affect the memory requirements and computational costs. So set it slightly above your typical sequence lengths to handle edge cases without padding it excessively. 100 is a solid value. You can go up to, I believe, 1,000, but this is a good place to start. You can increase or decrease as necessary. And then the final one that we'll go over, which I think we started as, did we pass it? Did we pass it? Let's trade. Optimizer. I don't see it, do I? I don't see it. No, they don't have optimizer mode anymore. Okay. But that was a good one to choose the accuracy for optimization. Um, maybe it's now this is optimizer metric. There it is. Okay. So this is the metric that the training process should optimize, right? You can choose accuracy here for straightforward optimization, BLEU for alignment with translation quality, or perplexity for probability focused optimizations. All right. And then you go from here. So let's stick with perplexity. We already went through the GPU. Okay, and then let's see. Yeah, we did what was it? Yeah, the ML M4 large or extra large. Just solid, right? So you can have more of these, and this will affect parallelization computation across multiple GPUs, right? Seq2Seq doesn't really support distributed training across multiple machines, so you can limit your maximum compute to a single instance, typically, right? So configure the storage volume. Let's try 50 gigabytes, right? That'll give you a good for a model that'll have like a large vocabulary. And then your training time, we went for that just to give you like an overhead. I mean, I wouldn't really want to get past 3 hours. It's a lot of compute. Um, but you'd have to test it for what you need. All right. And then training, we'll go back here. Okay. So the training portion, you can launch when you launch this and monitor this. You look at it through CloudWatch, right? And then the SageMaker console as well. So one new thing you're going to do is you can choose pipe or fail or file. File would be local. Pipe would be for production level. Does not need to start and download this from your S3 to your local, and then process through your pipeline. So let's file because we're just testing. Content type, record. Oops. 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 Okay. Compression type, none. Record wrapper, RecordIO, data source. We'd select fully replicated, shared by S3. Okay. Then you put that path to your S3 bucket, right? And you can also add another channel if necessary. All right. So from here, you can monitor your scores and validations in the SageMaker console, and the training duration will vary dramatically based on your configuration. So small vocabulary can be finished in a few hours. A large vocabulary could take days. So consider using a pre-trained model when available to dramatically reduce the training time and costs. All right. And you configure your output bucket. You can do that to another one with a subfile, another bucket, or I believe you can do that to your own bucket with another, a subfolder. Okay. Or you have a local path you can do for local reference. And another, oh, that's a checkpoint configuration. Sorry. This is for basically how you save your game, right? The output to another bucket or sub bucket or a bucket with a subfolder. And then encryption to make sure that it's encrypted so that only you and anyone else who has the key can actually manage it. All right, add your tags, managing the spot training to save time, right? And the time to wait before termination. And you click create the job. All right, at this point, your model artifacts will be saved to your S3 once the training's completed. And these artifacts would have the trained network weights, the vocabularies, configuration metadata for deployment and any inferences, right? And then at that point, you could just reuse this to go forward with your training artifacts and deploy it in using whatever GPU is relevant, ML, P3, etc. Right? And the inference performance would depend on the sequence length and the model complexity. All right, but we're going to cancel out of that so we don't get charged. All right, so pre-trained model. All right, so the computational requirements, let me go over here. Okay. All right, so pre-trained models, right? So computational requirements for training Seq2Seq models from scratch makes a pre-trained model pretty valuable. So a public repo can provide models trained on massive parallel corpora for common language pairs, saving weeks of training and substantial GPU costs. So these pre-trained models can capture general language patterns and translation knowledge, and it enables immediate deployment of or fine-tuning of domain-specific data. Rather than learning language structure from scratch, you can adapt existing models to your specific vocabulary or style requirements through transfer learning. And then accessing the pre-trained models would involve downloading model weights and vocabulary files from public repos and deploying them directly through SageMaker or fine-tuning your own specific data sets. So there are example notebooks that are available that can demonstrate the workflows, and it can show you how to integrate the external models into SageMaker's training and deployment infrastructure. All right, and you could do that. Create and go your own algorithm resource, right? Or you could use the marketplace or your own algorithm container, right? This is how you do that. We're not going to do that. It's going to take too much time. I'm just letting you know. All right. And that's the model training portion. You should really look at that because it's an interesting walkthrough. We're not going to go through that. So we're going to finish off with pricing. All right. So Seq2Seq's GPU requirements creates cost considerations that demand careful resource planning, right? So a P3 instance can range from $3 to $5 per hour for a single GPU configuration to significantly more for multi-GPU instances. And then the training jobs often run for extended periods. We talked hours or days. So think about that. So the cost optimization starts with training your training time estimation. So you can start running small scale experiences to kind of gauge what your costs are going to be and then extrapolate that to the full data set, right? So this can help you make an informed decision about whether to pursue a custom training or leverage a pre-trained model, right? So, and then remember we showed you in there the spot instances. Consider using that for non-urgent training workloads. And it could really reduce your GPU costs by 50, 70, 90%. And Seq2Seq training, it does support that checkpointing, which works in conjunction with spot interruptions, so you won't lose all your progress, right? So this will work for experimental training where completion time has flexibility. And then you monitor your training, right? Do it actively. Don't just set the maximum runtime and walk away. If it stops based on validation metrics, this can prevent unnecessary training after the models converge, right? So then you can save costs, and then you don't have to sacrifice your performance. And then you can also set CloudWatch alarms to notify when your training completes or when your validation metrics show convergence, right? So consider using this. But remember, for translation, intelligent summarization, and accurate transcription, you have to justify the investment for the applications. So you have to make Seq2Seq make sense for a business value. Anyways, thank you for joining. We appreciate you. Next time, we're going to go into deep AR. But before we go, hit the like button, subscribe, share this with anyone you know taking the AWS machine learning exam.